So a lot of people are asking us about performance and concurrency. It's all good that you're able to run queries real fast, but what happens when there are 100 different users who are trying to access the data? What happens to your performance then? So what I want to show you today is essentially what happens when 100 different users are trying to access the same data set in Firebolt and how Firebolt can still deliver sub-second performance. So let me share my screen. All right, so let's start with the data set itself. So we have a table here that is called user metrics. We can see that we have approximately 4 billion records in it. Let's see the data real fast. So we have a user ID, some date, and some metrics. Now let's see the Python script that we're going to use in order to run the queries programmatically. So we're going to start with a very simple iteration. We're going to start with just one client that is going to run 10 queries, but note that those queries are completely randomized. They are generated automatically by the script. So there's no result cache or anything like that. The data is warm, but we're not using any sort of cache. So let's start with running one client with 10 queries that are running essentially one after the other. So let's start by running the script. So we're going to see one client that was being connected, and then essentially 10 queries that were executed one after the other. Here we see the final results of this iteration. So one client ran 10 queries, and the average execution of the query was essentially 11 milliseconds. So now let's start taking up a notch the number of clients to see what happens when we start adding some concurrency. So let's start with 10 different clients that are trying to run 10 different queries each. So again, running the scripts, we see that 10 different clients that we're trying to connect to begin with. And we are actually ending with performance, which is quite the same as we got before. So although we have 10 different people that are accessing the data right now, we're still able to deliver the 10 millisecond performance on average per query. And again, those are completely random queries. Let's see now what happens when I'm actually going all the way up to 50 users in parallel. So again, 50 different sessions right now. Each session is running 10 queries each. And we are ending up with essentially 31 milliseconds on average per execution. So we do see a slight increase, but we're definitely in the low range of sub-second performance. Now again, the ultimate test, what happens when I go all the way to 100 different users that are querying the data in the very same second. So let's run that right now. So 100 connections, 100 sessions, and we can actually see right now, just by the speed of execution and the amount of results that we're getting back, that the performance was still very, very efficient. We essentially went all the way up to 0.1 seconds, but definitely still in the low range of sub-second performance. Now, just to prove to you guys that actually I just ran 1,000 unique queries that were completely generated and were not cached, let me just show you what happens when I run this simple query over our catalog table and looking for essentially distinct queries. So if I run that, I will get exactly 1,000 queries, which is 10 times 10 queries that were executed by 100 different clients.